Good afternoon, grade 7 students. What I'm doing today is showing you a quick, easy at-home experiment to demonstrate how you can choose a topic of something that we've studied this year and turn it into an educational video for our Bill Nye the Science Guy final culminating activity, if you will. So I've chosen conduction. Conduction, if you remember, is one of the 3 methods of heat transfer. And I've got the definition from the internet of what conduction is, and I actually need a piece of paper to read it because it's a little wordy and bleh. So the process by which heat is directly transmitted through a substance when there is a difference of temperature between adjoining regions without movement of the material. Okay, that's just a fancy way of saying that if there's substances or materials that are touching and there's a heat difference. So let's say there's heat over here, it's touching something else. The heat is energy and heat can move through the material. And so the heat goes from here to here simply by moving through something. So I've got a simple experiment here to show you how conduction works in a nice visual way. So I've got 3 spoons. I've got one that's plastic, I've got one that's metal, and I've got one that's wooden. And what I've done, if you can see, is I've just popped a little bit of butter. I tried to make it the same amount, but hey, let's just be real. I just did this on a whim. So there's 3 spoons with butter, and what I'm going to do is attach a Cheerio, because I don't have beads. The experiment said, hey, put some beads on the butter. I don't have beads. Kids eat beads. Beads choke kids. So I've got Cheerios. So I'm going to stick a Cheerio, and it's just meant to help with the visual so that you can see once the butter has melted, the Cheerio will obviously fall off the spoon. So here we go. I'm just going to stick a Cheerio to each little pat of butter. And I do have a cloth inside the cup, and it literally does nothing except I've tried to make sure that the spoons are all at the same height just to keep my variables as similar as possible so that I know that conduction is what I'm witnessing, not in the way that I've set it up, and it's just too different and I'm getting different results. So I have my hot water here. I've just boiled it. I'm just making sure that I'm not missing anything before I start. Okay, so I'm just going to dump some water in, and we'll talk about conduction as we wait to see an example of conduction. So what I'm going to do though here is hot water obviously lets off steam, and I'm talking about conduction, not convection. So what I'm going to do is I'm going to put this cloth on top, and the only reason I'm doing that is so that the steam isn't what's causing the butter to melt. I don't want the steam to kind of come up, hit the spoons, and then the butter melts all over because of convection. That's not what I'm trying to prove here. So I don't know how long this is going to take. So here we go. I'm just going to try to move the camera a little closer so you can see it. But let's... You can see some action happening here. You can see the butter traveling down the metal spoon. I don't see any butter moving on the plastic or the wood. I only see butter starting to move through the metal spoon. And there it goes. So I'm just going to move this back so you can kind of see. It didn't take that long, but hopefully I learned how to edit film, and you didn't have to watch the whole thing. If you had to watch the whole thing, that means I didn't figure out the editors. Whoops. So here we are. So what has happened? Why has the butter melted only on the metal spoon at this point, not the plastic spoon, not the wooden spoon? If we're talking about conduction, then we also have to talk about conductors. So metal, you've probably heard of it, are good conductors. That just means that metal is really good at allowing energy to flow through. There's a whole long explanation about free electrons and blah 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 blah. We don't need to go there. All we need to know is metal is a good conductor, which means it allows that heat energy to transfer through really easily and really quickly. And that's why the butter melted on the spoon, because the heat energy from the water traveled up the metal spoon and melted it right away. And you'll see the other spoons are still same as. So let's talk about some other real life examples. So for example, at a campfire, maybe you are roasting a marshmallow or cooking hot dogs over the campfire, and you're using one of those like campfire rods, but they're usually made of metal. And you might notice that your hands are getting hot because the heat transfer from the fire is going into the metal, and that heat energy is transferring down to your hands because it's metal, and metal is a good conductor. We all know that if you want something to heat up quickly, like if you're cooking, you're not typically using wood or plastic to cook with, you're using metal. So that's another really good example of conduction. You go, you put your pan or your pot on the stove, you turn on the element, that's your source of heat, and it conducts heat through the metal of the pan or pot and goes directly into the food that you're cooking. Another example is maybe you have a wood stove at home. Remember, everybody always said don't touch the wood stove. If you touch the side, you usually burn your hand, because metal, while it doesn't burn or melt when you create a fire inside of it, it is a good conductor, so that heat from the fire on the inside actually does transfer through. So you can feel the heat of the fire on the outside of the wood fire oven or stove or whatever you might have. I really hope I learn how to edit. Okay, bye-bye. Anyway, I hope you learned a little bit of something and how to make a simple experiment like this work for you in your final project.